Well, hello and welcome to my shop here. It's October 13th. My gosh, it's been a week since I've been in my shop doing any work. That's about the longest break I've taken in years and years here, believe it or not. So, last thing I was doing was testing tubes. When I got through testing two tubes, was the output tube over here and the FM tube. Both of them proved to be weak. I have replacements in here now. The result of that is the AM radio side of things got a lot stronger, a lot louder. I'm going to have to turn the volume up about that much, pretty normal. So I think that's a pretty good thing. But on the FM side, I'm going to turn the volume all the way up to the top. This is not plugged in or turned on right now. So to get any decent sound out of it, and decent, it's not even decent, it's terrible in fact. So something is still quite wrong with the FM side in this radio. As a guess at this point, I would guess bad alignment could be the cause of the problem, but there still is 3 more tubes to test. 1, 2, 3 back here. Those tubes are 2 EF89s, the same as a 6DA6, I think it is, 6DA6, yeah, same thing. And this tube, the EABC80, this is a very busy tube. Now the AM signal passes through these tubes, and the FM signal, the intermediate frequency, passes through these tubes. So you'd think, well, if one can pass, why can't the other? Well, part of it is there's a very big difference between the IF frequency of the AM radio, which is coming in around 455 kilohertz, which is quite low frequency-wise, you know, relative to everything else in this world. It's really low. But the FM side uses a 10.7 megahertz signal to go through these same tubes. It's possible that the tubes work okay at the lower frequency, but they are too weak at the higher frequency to operate. It's possible. It's not terribly likely. Chances are, because the AM side is working well, these two tubes are okay. And what are these two tubes doing? Both of them are RF amplifier type tubes. They're increasing the strength of the RF signal. We'd have to look in the schematic to know exactly where they are, but one of them is bound to be, it's probably this one here, bound to be located electrically or electronically between the two IF transformers. So if this were the tube, and it probably is, this is the one that produces most of the gain in the radio. Not all of it necessarily, but most of it. At least at the RF side of things. The audio gain is produced by these two tubes. So that's a pretty important tube. So it's this guy and this guy. This guy is probably an RF amplifier, probably amplifying the IF frequencies that's being developed in the radio. I'm not sure about that. Somewhere there has to be a mixer tube. What's happening here? How can this be? That's interesting. Where are they doing the mixing? Is there another tube in here I'm not seeing? No, it can't be. It can't be. Okay, so we don't need to worry about that right now. We just need to test these two tubes. Okay, let's see what happens. I'll get set up to do the tube testing here. Okay, here we go with the first tube. This is the RF amplifier one, the one that's right at the start of things in the radio, more or less. EF89, it says on it. That's good. We'll just double check this. So this is a 6DA6, and it says right on it EF89, right on the tube tester here. So for sure I got it right. 6.3 to 34L. I set all this up ahead of time. 05176, 05176, 0342, 0342, 34D. Okay, we're good. We're good to go. Okay. Just give it a moment to warm up there. This one, if it tests good, is going to test at 1170, above 1170. So that's above where my finger is now. First, we'll look for shorts. Wouldn't expect to find any. All is clear. Here we go. How good are you? Well, it's right on the reject point. So, if I was into selling tubes, I might be able to sell one right here. But I think this is good enough to work, and the radio wouldn't probably explain the weakness in it. Can't be sure though. This test doesn't test the tube at different frequencies or anything like that. But it's basically right on the rejection point, 1170. Yeah, well, that's that one. Okay, so I'm going to stick it back in the radio in the same position it was in. Because there's two of these same tubes in the radio, we have an opportunity to swap them as an experiment. Both those tubes have a little bit of tape on the side of them, which means these are original tubes. They were taped in place originally by the manufacturer just to make sure they didn't fall out. Probably during transportation was probably the issue. They're not going to fall out sitting in your home. I'm looking just to make sure it certainly looks the same as the other two. I'm just looking for the label. 274. Well, it's got this number 274 on the top of it, and I don't see a label. But it has the tape. Isn't that unusual? You'd think these... Oh, there we are. Well, maybe that's not the label. I cannot read the label. But I think we can be pretty sure this is the right tube. 274. The other tube have that? The other tube has 274 written on the top also. So I'm not exactly sure what that means. But I'm not too worried. I've got the wrong tube here. This is not very likely. Once in a while I'm handed a radio to work on that the owner doesn't know anything about. They've just acquired it and handed it to me, and when I go through the tubes are either in the wrong sockets or they aren't even the right tubes. Somebody's just put tubes in to fill the sockets. So you never know. But that's not the case here. The radio operates, especially on the AM. Okay, any short in this tube, short or leak? Leak would be a partial short. No. Okay. Here we go. Well, I think you could probably argue that this tube, it's below the rejection point. I see the pointer's still coming up a wee bit. The tube is still heating up a little bit. So again, this wouldn't stop the radio from operating, but might weaken it, especially with the higher IF frequency. I really don't know, to be honest with you. So potentially replacing these tubes with known good ones might be a good way to eliminate them as a source of the weak volume on FM. So I think I'm going to look for a stronger replacement. It's working its way up to the reject point. All the way up to the reject point. Good tube. We don't know with this tube tester what it would test, but generally speaking it would probably be up in this area here. Okay, there's one more tube to test over here, and that's a very important tube, the detector tube. Let's pull it out. So it also has some tape on the edge of it. And you look inside, can you see? It looks like there's, hard to see here, 3 different sleeves, if you like, in there. Yeah, there actually is. There's actually, yeah, you can see it there. There's actually 3 different tubes inside this tube. 3 in 1. E, A, B, C, 80. And like I mentioned, the tape is on it. Okay, I'll have to get this one set up. It might be a little more tricky to get that in the tube tester. So I will attend to that. Okay, so to completely test this tube, I have to run 3 tests on it, a test for every different section in it. The first test is for the triode section. The other 2 sections are diodes. So let's just make sure. 6.3 is the voltage. Good, we can plug this in now. Okay, I'll just double check the rest of it while it's warming up. Signal level 1, bias 25 low, 00076, 00076, 0153, 0153, 32, F. 910 is the reject point, so a little below 1,000. So around there for the triode section, and you've been looking at the wrong thing the whole time here. So let me just do that. I'm gonna quickly. Okay, so well, you heard what I said. I'm sorry about that. Hey, what did I say? I talked to my producer after the show. So we're ready to go here. Here we go on the leak test. No leaks visible. Okay, and we expected 910, which is up about here. So it's right. It's actually in the rejection zone. Now, what I like to do when I'm looking at a tube that's weak and wondering should I throw it away, we shouldn't be throwing away tubes left and right here just because they show up weak on a tube tester. Doesn't mean they're too weak to be used. Maybe back in the old day when there was 50 of these on the shelf, yeah, but there aren't 50 of these on the shelf anymore. So we shouldn't just be throwing them out. So I do a little sensitivity study. First I wiggle this meter sensitivity a little bit just to see if, you know, if the dial were just turned a little bit this way, she's good. 52, and likewise with the bias. How sensitive is the bias? You see, just a little wiggle. So if on this machine the bias it's producing is not directly related to the setting was 23, wasn't it? 30, 25. This were a little out, like the machine's a little out of calibration, and this is a little out of calibration. This might rise up enough to, you know, be above the reject point. So that's my point is, as precise as this looks, it's not precise enough to decide to kill the tube. But maybe putting another one in there might be a good idea. Now we'll test the two diodes. Next setting, I'm just going to let the video roll here. So the next setting, a couple things. Signal doesn't matter, bias doesn't matter. 00076, 3100. So we're going to pull this out while we do this, because I'm not sure if you can leave it in this tube tester. Some tube testers you can, some you cannot leave the tube in while you're changing settings. Sensitivity 45. For instance, this plate setting, which goes over to 8, that's pretty important. Just flipping that switch around, it's going to put the voltage on the pins as you go around, I think, in this tester. I don't want to find out. I have another tester that I know for sure you can change all the settings. Nothing is applied to the tube to push the test button. But I don't know about this one. And I know I've got at least one tube tester that I have gone and turned these controls while the tube's in. You should not do that. You should not do that. Unless you're sure. Okay, looking for shorts. Okay, so now we're looking at a diode test here. So we're clicking this switch, not this one, a diode test. And for diodes to be okay, it just has to come up into this diodes okay window I'm pointing at down at the bottom here. That's all that's got to happen. It's right on the bottom of it. Okay, there's one more test to pull off here. So this was one diode in one of those 3 cans we could see in the tube. We're going to do the next diode, but it's actually 2 diodes inside the 1 can. So again, I'm going to pull the tube out while I'm adjusting this. Make sure my eye is lined up right. P3176. P3176. 0K00. 0K00. 38 on the sensitivity, and the plate remains A. Diode 2 and 3 PK and PK. So to switch between the two diodes we're going to test, we flip the P and the K buttons. So the plate and the cathode buttons get flipped, and then we test the other two. The other diode. Here we go. Put it back in. So what makes tubes go weak over time? So there's a cathode inside these tubes, and the electrons are being emitted off the cathode. Cathode is chemically treated with a special coating that makes the electrons easy to drive off, so you don't have to heat the tube up too high. Early tubes, the filament had to be white hot to operate, but engineers and scientists learned that different materials emit their electrons at different temperatures and different volumes. They discovered a powder that could be welded onto the cathode, and then that powder, kind of like a ceramic powder or whatever, oddly enough, emits electrons better and easier at a lower temperature. The problem is, over time, the action of heating it, the electrons with their energy, they're not all coming off, right? A lot of them are just banging around. It wears out the cathode over time. And eventually, cathode kind of burns off. I don't know if that's the right word. Becomes contaminated. Eventually, it can't issue electrons anymore. Its emission gets poor. And that's probably what we're seeing in this tube. Because the first section with its cathode was low. The second diode, the second section we did, was low. And this one, again, a big speech without finding out if it's really true. No shorts. Diodes. Well, we're up a little higher here. And the other diode, much higher. So the three of them are all testing differently. These two diodes we're testing now, I'm sure, share the same cathode, so why one reads higher than the other, I haven't got a story for that. I have not got a story for that. So what do we got here? So we got another tube that's kind of borderline, would probably work, but may not be producing as much gain or effect as it could. Especially the weak diodes could be weakening the signal. And again, well, let's see, in this tube, yes, there are RF frequencies reaching this tube. So on AM it's operating around 500 kilohertz, but on FM it's operating around 10 megahertz. That's much, much higher in frequency. So maybe it's frequency sensitive too. Works okay at the low stuff, not so good at the high stuff. So I just about convinced myself now, at least I got to do this one tube at a time. I have to eliminate these tubes as causing the weakness in the output. And the only way to do that is to substitute. Now, there could be many other things causing problems in this radio yet we don't know about. So it's not necessarily tubes. This could really be just an elimination of tubes as being the problem. So we can move on to something else. And I'm going to move on to a cup of coffee for a few minutes. And then we're going to carry on here with this. I have to hunt down some tubes. Okay, well, a possible replacement for a EABC 80 is this tube, 6T8. You can see the three sections in it there. It's the same tube, basically. It's just an American version, or North American version of it. Okay, so I have this set for the triode part of this tube to start with. Just double check. So 25L and 00076, 00076, 0153, 0153, 32. F. So this is now set in accordance with a 6AK8. What I'm going to do now, this is a 6T8. I'm going to dial up 6T8 here and see if it's the same setting. That would reassure me about using this as a S6T8. So here's the numbers. so first 27L, slightly different here. Signal level 1. 0076, 00076, and 0153, 0153. It's the same settings. F and the sensitivity setting is 33. Same. Okay, it's exactly the same. So that reassures me this is a proper duplicate. Substitute. Okay, we'll plug it in. Now I don't know if this tube is, I know this tube is working. If it's in my collection, it works. How well it works, though, is something we have to test for before I use it. What I do is when I acquire new tubes is I run them through some simple tests just to see that they function. The heater is going to heat up and the tube shows something on the scale. And then that's good enough, throw it in my collection. Somewhere down the road I pull it out in circumstances like this, then I test it more carefully. And I have a number of these. Okay, let's look for shorts here. None. Now, is this tube any better? So we're expecting this to come up to 780. Well, that's not the same number, is it? 780? I thought it was 11 something. Okay, let's go back and look at the E6A, 6DA6, wasn't it? 6. I'm getting lost here. ECD, come over here, DA. Yeah, 6. No, that's the EF89. Can't remember the number. Okay, let's carry on where we are. I won't worry about going back. So it's just a difference in where you read it on the screen here anyway. So did I check for shorts? Did I already do that? I think I did that. Did I do that? There we go. Oh, it's way up there. It's way up there. Excellent. Now there are 2 more sections, and probably don't need to test them. 6. I'm going to do it with a 6T8 because I can remember that. 6T, T8. It's bound to be good though, I think. 30076. 30076. P100. I don't remember this being matching the other tube settings. 35 on the sensitivity. A plate P1 and P2. It seems to be tested just a little bit different than the other one. But they are direct replacements. Give that a moment. Shorts. Diodes and rectifiers, and again, it just has to come up into this zone here. She's a good one. And just because we've gone this far, we might as well test the last part. It's a 03176. 03176. 0, 0, 0, and a 0. All zeros. That's a little odd. Go back in. So, take it out. Put it back in. Okay, I read the wrong part of my chart. Very easy when you're doing these tube testings for your eye to pick the wrong spot on this chart. At least for me, my eye does that. Very easy to make mistakes. Actually, I have a lot of skill in making mistakes. There we go. Seem to get a lot of practice. Here we go. Oh, what happened there? We got a nothing. Oh, I'm pushing the wrong button. No, I'm not pushing the wrong button. Tube not making contact. That's what's happening. My sockets are worn out in the tube tester. That's all. Way up in the good. We're in the good. Okay, so I'm going to put this in the radio. We're going to play the radio and see if it doesn't work better on FM. This is the goal of the situation here. These are my 6T8s. This is the original tube that was in there, which I don't want to mix up. Put it over there. That is not the original tube that was in there. The original tube is here. It's in there. Okay, don't know what I'm doing, but I'm doing something. We'll put this tube in. Where did I get this one from? Oh, that's right. I pulled it out of the bag. And instead of being a 6T8, it's a 19T8. And that won't work for us. Okay, let's just keep going here. Well, maybe I'm going to stop. I'm going to stop for just a moment here. Okay, here we go. Let's see. So we're going to start with it off. Oh, scared me there. Start with it off. Good. No lights. Medium wave, volume down. Did I stick all the tubes in? Yeah. Okay, let's give it the full works. Oh. So on AM it's working and the volume is there might be a little bit of dirt in the volume control there. Volume is good. About the same as it was. So all I've done is replace the one tube, the EABC 80. Okay, let's go on FM. FM antenna is connected to this. Oh, that seems better. That seems better. Let's see what we can pick up now. Oh, see it go quiet? The volume's full now. Could be because of the tuning of the antenna. May not be. Frequency we're at is we're up in the higher end. This gets louder and louder, quieter as we go down. So, that suggests an alignment problem. And it just fades right out. It's not picking anything up. Now I changed the FM tube. Let's change it back. So I'm taking out the replacement I put in, which is probably a better functioning tube. I'm going to put the original back in. I'm going to see if this makes it quieter. I'm sort of proving what I did previously. So sooner or later it should go in. There we go. The shield on. Back on. See if it's any different. Wow, that was exciting. That could be another sign. Well, it could be a sign of a lot of different things. That can be a sign of bias problems. As the set warms up, it passes through a good state, but it warms up into a bad operating state. So we got much less hiss. And the hiss is the same all the way across. Yeah, scratch your head on that. We're certainly better off with the other two. Ooh. going on there? Where could that hum come from? How did that happen? What was I moving when I was turning this? So I have the AM antenna hooked up. This may end it. So probably what's happening here is because my shop is running, the radio is running on a isolation transformer rather than being plugged right in the wall. That may be causing that hum, and I applied a ground lead here and the hum went away. So that's probably what that is. But I'm not going to worry about it right now. But we still have next to nothing here. Okay, let's go back to the replaced tube. This is more or less verifying that the tube I replaced needed to be replaced. You know, it's quite easy doing this and almost everything else in life to get the wrong idea in your head. And then, you know, as human beings, we tend to sort of register our ideas as being final. We tend to not go back and sort of prove again what we believe to be true really is true. That's a big problem with people. Come on, let's go in. There we go. Lots of big problems with people. Now, somebody should have not let us monkeys run the world. Here we go. There's that sound again. Didn't matter which tube was in. That sound could mean anything. I had the volume right up full. See it getting quieter? Quieter? As the voltages are coming up, something inappropriate is being applied to one of the tubes. In other words, like there's an operating range and a voltage is supposed to be in it. And what could be happening is, as the radio warms up, it passes through the operating range whoosh, and then out the top. Could come up into it and then fall down after. Who knows? I'm making that up. Okay. Lovely hiss here. I'm pretty sure I put my signal generator onto it the other day. I then left it on for 3 days by accident. But with the signal generator, it was picking up weekly. Okay, well, the problem could be the other two tubes. So I think we've got an improvement with this one changed. We have an improvement with this one changed. So let's carry on. We'll do these two. Maybe a very simple thing I can do. I can swap them. Are they hot? They're the same tube, so I can swap them. They aren't that warm. Not yet. They're both, I think, measured weak, so, you know, swapping weak tubes around probably not going to do anything, but this goes in the category of easy things to try. Easy, no risk things to try. It's worth trying. Okay, so I could hear the hiss up here now. So swapping those tubes actually improved the operation of the radio. I think the real deal is put some better tubes in here. And I think maybe the thing's going to operate. I don't know. Got to try. Got to hunt down two EF89s or substitutes for them. Okay, got a couple possible replacements. 6DA6. Let's see what's actually in here. Sometimes it isn't. Ooh, that doesn't look like a 6DA6, does it? 6DA6 looks brand new. Brand new. Okay, let's just take a look at our settings here. 6DA6, 6.3 volt filament, signal level 2, 34 low, 05176, 05176, 0342, 0342, 34 D. Very good. Well, this is going to test good, I'm sure. So, an interesting question: does a tube wear out just sitting in a box? You know, maybe over 1,000 years it does, but no, I don't think it degrades. It is possible that, especially with some earlier tubes, there are materials and components used inside the tube that can give off molecules, or I don't know how to put it exactly, gas off a little bit. The tube comes with a technique for removing the last vestiges of gas. That's this dark or shiny color you can see on tube, sometimes on the side or various places. That material absorbs molecules, ions, or whatever's floating around in the tube that shouldn't be there. So as long as that's good, the tube remains gas-free inside. There we go. What does a brand new tube do? What appears to be a brand new tube. So 1170, about here. Oh, it's really cooking, isn't it? It's probably the socket here. Heater's definitely on. Yeah, it's just a socket contact. It's gonna look. It's right up around 2,000 there. Yeah, just a socket contact. So this is a beauty. Okay, now I have another one. Oh, what's this AB for? That's not what I'm after. How come I pulled this box out? Because it's this box. That's why. EF89 6DA6. Somebody's written on it, so there's a good chance this is a second time around tube. Looks pretty new. EF8. Wow, somebody's like rubbed it off there, but I see enough of it to reassure me. EF89. If it's not an EF89, we will soon find out. It won't do well in the tube tester. Okay, give it a moment. It's heating up very slowly. No shorts apparent. Is it warm enough? Oh. That's not particularly good. Let's try that again. Here we go. Okay, so it could be tube in the socket, so I'm wiggling the tube and seeing if it'll jump. No, it's not going anywhere, is it? Yeah, I can't get it to jump up. So either the tube is not the right tube, or it's just not a good one. I think it's probably just not a good one. That's probably the case. I gotta find another one. That's very weak, but as I said before, if the tube operates at all, I keep it in my collection. Okay, so I'm going to hunt down another tube here somewhere. Okay, it turns out, at least at this point, I've only got one good replacement. I think I've used my other good 6DA6s in other radios, and they're gone. So, what I'm going to do with one good one, I can either put it in the IF position, or I can put it in the, this is the mixer tube here. I looked at the schematic, and they're using the same tube as a mixer. They're using the signal grid for the antenna signal, and then they're using the screen as the second grid to mix on. That's how it looked to me. But I'm going to put the new tube in here. I'm going to go in the middle position. I think this might have the biggest impact on the radio. I'm not sure. And one of the two originals is a little better than the other. I can't remember which is which, but we'll try both. Try one at a time. Okay, here we go. Based on the level of FM hiss. It's tuned down here in the hissy end of things. That didn't seem to help much, did it? Working about the same. Fading out down here. So I'd say it's working about the same. Okay, we're going to put the new tube in the first position here. Well, I don't know what just happened now. My shop computer that I make these videos with just suddenly shut off. And I have no idea why. Stopped seeing the keyboard a few minutes ago. I had to reboot the thing. And now it just went away. Okay, so anyway, what I've done, because I don't know what got caught on video, I've put the really good one in the first position, and I've moved the tube that was here over here. We still have one original sitting out here. We'll try it like this. Everything's still working? Hello, hello. Seems to be. Hope my computer's not breaking down. The last couple of days I've spent trying to restore a Windows computer for my mother-in-law laptop, which I believe she never ran an update on it for 2 years, and it just slowed down to a crawl, and then it just wouldn't work. And for the life of me, I could not reinstall Windows on it. What a mess. We ended up buying her a new computer. So yeah, if I'm not in here, facing all this stuff, I'm doing something else, facing all that stuff. Great thing is this morning I did get Windows installed in it. Okay, I think we're ready here. Well, that seems a little louder. And we're up at this end. It still has that same drop off. So, now the question is, what happens if I put this tube in? Let's just do it. Do it live. Do it live. Is it even better? I think so. I think that's louder. Quiet here. Yes, this antenna requires tuning also. So it could be the roll-off is just due to this antenna. Could easily be the case. Frankly, I don't really know how effective this antenna is. I've fiddled with it before. Well, let's try another type of antenna. So, take this off. That's a no antenna. This is the outdoor antenna. It's not appropriate for FM. This will put a ground here. It's just going to kill it. I don't want that to happen. Well, I don't have much else for an FM antenna, but frankly, a little bit of antenna, this thing should be receiving stuff, and it's not. Is it because of tubes? I don't think so now. I think I've done enough to say it's not caused by tubes. And I did demonstrate changing this one with the original, quieted it. Doesn't really prove that this is a great tube, but you know, these tubes don't have to be perfect to do a reasonable job. The volume control compensates for a lot. Bit of a hum in there too. So possibilities now: components, bad capacitor somewhere. That would be a good deal if that's all it is. Or it's alignment, and all these little alignment things have to be fiddled with very carefully. Not fiddled with, but worked on very carefully. I think that's it for today. Let's just right down here. This is without an antenna. Oh my gosh. Medium wave, and putting on the FM antenna. Must get its way through somehow. Okay, a good place to pick up AM radios down here. Yeah, it's, even though we're hearing noises, I recognize them all. Especially that buzz. Isn't that terrible? So we're not going to pick anybody up. But it's certainly producing lots of volume. Okay, that's where I'm at for today. Tomorrow we'll start working on replacing capacitors and see if we can't, along the way, pick up the FM. Maybe we'll focus on that. We'll try to pick some capacitors that may influence the FM side of things, and or other components. Or you know what I could do too? Maybe a better move would be to do a voltage check across the radio, make sure the tube voltages are correct, and then after that, go after capacitors. Although checking the voltages may reveal something. Anyway, thank you very much for watching, and hope you enjoy your day. Bye.